Okay, so if I was teaching young kids to count and multiply, I'd probably, use something like this where you use buttons or jelly beans or little coffee beans or something like that to sort of count, but to sort of do them in boxes with rows and columns. So let's say we might go, okay, so some buttons, 1, 2, 3, 4, 5, 6. Okay, here's some jelly beans. And put them in a couple of rows, or 5, another 5, well that's 10. And let's have a dozen or 12 coffee beans. Okay, get them to count them, get them to draw them. And then you sort of notice, okay, well, we can just save ourselves drawing all the little jelly beans and things, and we can just count the little boxes. Make a big box and count the little grid cells inside. So here's 3 by 2, 3 rows, two rows of 3 each. That's 2 by 3, 2 by 3, and 10. Here is 2 rows of 5, so it's 2 by 5, and a dozen coffee beans is 3 rows of 4. 3 by 4. So 2 times 3, or 2 rows of 3 is 6. 6 of these, and 2 times 5 jelly beans is 10 jelly beans. 3 times 4 is 12, or a dozen. Excuse me, we'll move that out of the way. Here's another one. What's 4 times 5? So okay, it's 1 row of 5, 2 rows of 5. This time we're using, look at marbles, different color marbles for the second group. And we have 2 rows of these marbles and 2 rows of the other marbles. So together we have 4 rows of marbles. And so if we just draw it as a grid, as a box, we have 2 blocks of 10, 4 by 5, 1, 2, 3, 4 by 1, 2, 3, 4, 5, and that gives us 10 plus 10, which is 20. Okay, so here's a couple of questions you'd get them to do just to review, and of course you can make the bigger boxes out of the smaller boxes. Excuse me. Right, so here we have a 3 by 2, but we've already done 2 by 3. So 2 times 3 is the same number as 3 times 2. So we can do this one easily. That's 6. Here we have 3 times 3, which is 2 times 3. So that one is the same as that. So we've got 6 there and another 3. So it's going to be, it's going to be 6, 7, 8, 9. And that one we've done. And 4 by 4 is the same as 3 by 4 plus a bit more. So let's have a look at that. Okay, so that one there we've already done. It's the same as that, 3 by 4. And then we have another 4. So it's 3 by 4, which is 12. So it's 12 plus 1, 2, 3, 4. 12, 13, 14, 15, 16. 13, 14, 15, 16. So we know the answer to that one, which is 16. 2 by 4 is a little bit like this one here, but a bit extra on the end. So we can go, okay, well that one there is, that part there is 6 plus another 2. So 6, 7, 8. So 2 by 4 is 8. Let's drop that in. 8. Oh, my bad. 8. And 3 by 5 is pretty much like 3 by 4 plus a bit more. So there's the 3 by 4 part is the same as this one here. So we've got 12 there plus another 1, 2, 3. So 12, 13, 14, 15. So the answer to 3 times 5 is 15. Or we could say that it's 10 plus 5. Either way, 15. Okay. So if you want to figure out that any of these times tables, you can basically just draw the picture and count them out and figure them out. It's not magic, it's just drawing pictures, really. Okay, so let's do a couple of examples. 3 times 7 and 7 times 8. Okay, if you know them, great. If you don't, okay, we'll just draw the picture. Okay, so 3 times 7 is basically 3 rows of 1, 2, 3, 4, 5, 6, 7 each. 3 by 7. And we could draw that another way. We could split it up and we can go, okay, well 3 by 7 is the same as 7 is the same as 5 plus 2 more. So we could actually, if we don't want to count them individually, we can break it down into smaller little boxes and count those. 3 by 5 seems quite handy. And then there's the extra 2 on the end. So basically 3 times 7, equals 3 times 5. That's that blue area. Plus the green area here, which is 3 times 2, or 3 by 2. Okay, so it's made up of smaller chunks. Sorry, 3 times 5 plus 2 is 3 times 5 plus 3 times 2. Okay, that bit plus that bit. And 5 times 3, or 3 times 5 is, we got a 10 there, and we got another 5, so it's going to be 15. And 2 times 3 is 6. We kind of know that, but we can count it quickly. It's easy. So we've got 15 plus 6, and 15 plus 6. In my head, I would go, okay, well that's 15 plus 5 plus 1, so it's 15 plus 5 is 20 plus 1 is 21. So 3 7s are 21. So we've done this one. So 7 times 8. Okay, so 1, 2, 3, 4, 5, 6, 7. That looks all right. 1, 2, 3, 4, 5, 6, 7, 8. So that's 7 by 8. Okay, so we'll mark them down. And we could make that in 2 chunks. We could make it the top area there plus that bottom green area, which is 8 by 5, or 5 by 8, and 2 by 8. If we don't know that 5 eighths is 40, we could... Okay, so let's say we break it down. So 8 times 7 is 8 times 5 plus 2. Important to have the brackets. And 8 times 5 plus 2 is 8 times 5 plus the green area, which is 8 times 2. So we might know that 5 eighths are 40, which is great. But then we might go, okay, I don't know what 5 eighths is. So let's break it in half. There's 4 by 5 and another 4 by 5. 4 times 5, we could even break that down in a half and go, okay, that's 5 times 2 is 10 plus another 10. So one of these ones is 20 each. And we got 2 of them. So we'll write 20 there and 20 there. And likewise for the bottom, if we don't remember that 2 times 8 is 16, we can go, okay, well that's 2 times 5 and then another 3 times 2. There's 2 sub boxes in the green area. So we've got a 10 and a 6. So the top part is 20 plus 20, which is 40. And the bottom part is 10 plus 6, which is 16. And 40 plus 16 is 56. So 7 times 8 is 56. So you can see how you can go through and build up the whole, all the multipliers basically by drawing pictures on grid paper. Okay. Okay, let's do a couple of slightly larger examples. 7 times 10 and 7 times 9. What's 7 times 10? Sure you know this already, but if you don't, we can always work it out by drawing the picture. So let's draw it. We've got 10 by 7. Mark it in. We could chop that up into 10 by 1, 2, 3, 4, 5 and 10 by 2 chunks. And then we could split the top part into a 20 box, a 4 by 5, a 4 by 5, and a 2 by 5. And then the bottom into two 2 by 5s. And then we could add up all the bits. And basically 4 times 5, 4 by 5 is 4 times 5 is 20. And we've got another 4 by 5, which is another 20. We got a 2 by 5, which is a 10. Another 2 by 5, another 2 by 5. So we add it all up together. We have 20, 30, 40, 50 on the top, and 10, 20 on the bottom. So it's 50 plus 20, 50, 60, 70. So 7 times 10 is, no surprise, 70. Okay, no magic. What about 7 times 9? 7 times 9, a little bit. Do we really want to count all those squares? Well, we could. That's fine. But let's say we start with a 7 by 10 and we take away one of these edge columns. That would give us the right size, right? So we take 7 by 10 minus 1 by 7. Then that would give us 7 by 9. So 9 by 7, 7 by 9, yep. And we start with 7 by 10, larger than we need. And then we take away this slice here. So if I write that down, 7 by 9 equals 7 times 10 minus 1. 10 minus 1 is 9, so 7 by 9 equals 7 times 10 minus 1. And that is a 7 by 10, which is this big green one, which is too large. And this 7 by 1, which is this orange one, which we're going to take away. And that, of course, is 70. We know that from over here. And then we take away the 7. And 70 minus 7 is 63. So we've done this one without adding up all little bits and pieces, just by realizing it's a little bit smaller than 7 by 10. Very handy. Okay, let's do one more, slightly larger one, which you might not know off the top of your head, even if you've learnt your times tables. 13 by 13. So here I've marked out a couple of little guides. Your grid paper notebook might have thicker lines every 5, which is kind of handy. So anyway, we want to mark out 13 by 13, but we'll do it in a couple of chunks. We'll do a 10 by 10 and then the rest of it, and then add up the bits. So okay, so first we want to do a 10 by 10. It's 5 is 10, down by 5 by 10. Okay, 10 by 10. Let's write that in. 10 by 10. Of course, we know what that's going to be, but let's draw the rest of it. We actually want 13 by 13, so let's draw on these extra bits that we need. So up here it's going to be 3 by 10. And down here it's going to be 3 by 10. And then we've got that little corner which we also need. Draw in a different color, which would be 3 by 3. Okay, so we can actually count all the boxes and it'll all work out nicely. Let's just write that in. We've got 10 plus 3 times 10 plus 3, which is 13 by 13. So let's write that down. Okay, so 13 by 13 equals 10 plus 3 times 10 plus 3. And we can see that that's made out of 4 different pieces. It's made out of 10 by 10 plus 2 3 by 10s, but just say, let's just call it 3 by 10 plus 10 by 3 plus 3 by 3. Probably should have put some spaces in, but anyway. Okay, so 10 by 10 is 100. This one here, 10 by 10 is 100. We can count that out if we need to. Or just remember it. So 10 by 3 is going to be 30. And 3 by 10 is the same. It's going to be 30. And 3 by 3 is just 1, 2, 3, 4, 5, 6, 7, 8, 9. So we add all those up together. We get 100 plus 30 plus 30 plus 9. Sorry, my bad, 9. Which adds up together to be 169. Okay, easy, cool. Actually, we don't have to draw it all to scale. We can draw a simpler picture, not to scale. We don't even need graph paper. We could still do the diagram, and it would look something like this. We could just draw, excuse me, we could just draw some we could just draw a box of any size. We just draw these 4 different parts. We need a better box. Okay, so we can draw these different parts. And we can just label them. can just say, okay, that is 10, and that is 3, and that is 10, and that is 3. I mean, you can just say 10 times 10 is 100, 3 times 10 is 30, 10 times 3 is 30, 3 times 3 is 9, and then just add them up. 100, 30, 30, 9, add them up, and we get 9, 3, 4, 6, 1, 169. So you can just draw a picture in simplified form. It doesn't have to be to scale. We're not counting these squares. This one here is this diagram is exactly to scale. We count the actual squares. This diagram is kind of like not to scale, but if we keep track of the sizes, then we'll still get the same result. So it saves us a bit of drawing and measuring time. Okay. So we can make these rectangles and do all our times tables and even larger ones. So it seems quite handy. And what we notice by drawing all these boxes and chopping them up and adding the bits and pieces to figure these things out is that when we have these kind of diagrams that look like this, where I've taken one side and split it into two, keep the other side, or even more complicated ones where I split both sides and add them up to solve a problem, we kind of notice that there's a general rule. And if we make a picture of this general rule that we're talking about, we could have one box that is A high by B plus C wide, a larger outer box, and we can get the area of that, or the number of items inside it, the number of little grid squares, like we have for these multiplication problems. We can get the area by splitting it up into two problems, A times B and A times C. So if we write that, where A, B, and C are any of these three numbers, A could be 3, B could be 5, C could be 2, and it would work. Or if A was 10 and B was 10 and C was 4, it would still work. It gives a whole set of all these different multiplication problems. So we notice the general rule because we're adding up the areas. And so if we express that with A meaning one number, B meaning another number, C meaning another number, so it's three different numbers. So if we write that out as a general rule we can reuse all the time, we would have A times B plus C. That just means a larger rectangle with one side is A and the other side is B plus C long. And that equals, we've noticed that it's made out of two smaller boxes. One box is A times B, which is that blue one. And we have to add the area of the other box, or the number of squares inside it, which is A times C. So that length is A side, and that is C, so that's A times C, and that's A times B. So A times B plus C equals A times B plus A times C. A bit of a shorthand for writing that, excuse me, is AB plus AC. And this is called the distributive rule, or sometimes the distributive law. So basically we go back and just label this smaller area here, it's AB, and the small area here is AC. Okay, very good. I guess this is the start of algebra.